In this video, we are going to learn how to rationalize the denominator. So what does that mean? All it means is that we want to remove any radical sign from the denominator, from the bottom of our fraction. So how can we do that? The process of rationalizing a denominator is just to take whatever that denominator is and multiply the entire fraction by that value. So because my denominator is a square root of 5, I'm going to multiply by the square root of 5 on top and on bottom. Now, why does this work? Well, we know that when we have two identical values divided, so a number divided by itself, well, that just equals 1. And a number times 1 doesn't change its value. So 3 square roots of 5 times what is equal to 1 is still going to have the exact same value as we started with. But now it will be rewritten in a form where it is rational, where it does not have a square root in the denominator. So I'm going to multiply by that denominator, top and bottom. I'm going to multiply right across. So I'll get 3 times the square root of 5 over 5, the square root of 5 times the square root of 5. Well, 3 square root of 5. What's square root of 5 times square root of 5? Well, that's just 5. So now you can see why we multiply by that value, because at the end, we're going to get, we're going to be able to get rid of that square root symbol and have a rational denominator. So at this point in this question, we are finished. This is in its most simple form. I cannot reduce the square root of 5 and the 5 here because they are not similar. Like this is a square root of 5 and this is a regular 5. So we can't actually reduce those. We can only reduce the whole numbers. So where's an example where we might do that? Let's take this one, 4 over the square root of 8. Go ahead and pause the video and see what you would do to solve this problem. So I'm going to multiply both sides, top and bottom, by the square root of 8. So I'll get 4 root 8 over the square root of 8 times the square root of 8, which is just 8. Now, I can't simplify these because this is the square root of 8, this is 8. This is inside the radical, this doesn't have one. I can't simplify that, but I can simplify this 4 and the 8. I can divide both of these by 4. 4 divided by 4 is 1 square root of 8. So I'm going to erase that one here and just leave it as the square root of 8. And then I am left with 2 because 8 divided by 4 is 2. This is my final answer. Now, how do I do a problem where I don't have just a radical in the base, in the denominator? I have a binomial. Well, I'm going to do a very similar process where I'm multiplying by itself, but instead of it being exactly itself, it's going to be its conjugate. So it's conjugate. The conjugate of a binomial is the same binomial with the opposite sign. And that is because we want to eventually be able to get rid of this square root symbol. So I want to multiply by the opposite sign so that that square root symbol is gone. And if you think about how we multiply binomials down here, if I kept the same sign and multiplied it out, this would be my answer. And I still have this radical here that I don't want. But if I multiply by the inverse operation, those are going to cancel out, and I'll be left with an answer that does not have a square root. And that is what I want to rationalize the denominator. So back to our original problem, I'm going to multiply by the conjugate. So I have 5, and I'm going to change this to minus the square root of 3. I'm going to take that opposite value. So 5 minus the square root of 3. I'm going to multiply now. I'll have 2 times 5 is 10 minus root 3. And I'm going to multiply 5 times 5, 5 times negative root 3, 3 times 5, square root of 3 times 5, and the square root of 3 times square root of negative 3. I have done that work here, and that value is 14. So now I'm going to look, can I simplify any further? And I can. I can divide 10 and 14 by 2. So I would get 5 and 7. I'll rewrite that as 5 minus the square root of 3 over 7. So now these have the same value. They are equivalent, but this one is irrational and this one is rational.